Hi everyone, my name's John Maskell from JM Coastal. This is the first part in a three-part video series about building a coastal model using open source software and some tools that I've developed. These videos aren't designed to be detailed instructions, but if you've never built a coastal model before, or indeed never built a coastal model using open source software, they hope to give an overview about some of the tools available and some of the processes involved. However, I may well do a detailed instructional video in the future. Some of the techniques and the tools featured in these videos will feature in more detail in an up-and-coming blog post. You'll be able to see this blog post and my other blog posts on my website at www.jmcoastal.co.uk. The first video in this series focuses on mesh building and viewing the computational mesh. So let's dive straight in. The first task is to prepare a coastline for the model domain. The coastline extractor tool makes this easy. You simply draw a polygon around the region you want, click select and download a zip file containing the coastline shapefile and a WKT file of the selected polygon. This way you can clip your own coastline in GIS software should you like. The coastline can then be imported into Blue Canoe, converted to the format required for the software and resampled as required. The open boundaries are then closed and an initial mesh is generated based on the domain geometry. Bathymetry data from scattered points can then be interpolated onto the mesh. A second mesh can then be generated based on this mesh, where each node value represents a resolution criteria based on the water depth. The mesh can then be used in our mesh generator as a density criteria and a new mesh geometry generated. Once again, we interpolate the bathymetry onto the mesh, where increased resolution in shallow water can take advantage of any high resolution bathymetry you may have. The mesh can then be exported and a boundary conditions file generated. The Mesh Viewer tool allows you to examine the mesh on a map. You simply upload your mesh, choose the correct projection, click select and download a KML file containing your mesh. You can then drag and drop this file from your file explorer straight onto the map. This way you can view the mesh and examine all the regions, inspecting the mesh so that the desired features are resolved adequately. Another tool available is the Terrain Viewer tool. You can select a region on the map by dragging the red square, choose a render and an option to view the mesh. Here is an example from the Lake District with a satellite imagery render. Another example from the Essex coast with a red, green, blue render which is based on elevation. Here the model resolves the coastal defences and the estuary and its various tidal creeks. Higher resolution models can be generated that resolve smaller features such as buildings and coastal defences. In the example, we see the dike, which is highlighted in green, is shown by the model and resolved in high resolution by the computational mesh. Well, I hope you found the first video in the series interesting. The second video will focus on carrying out a tidal simulation using the mesh generated in the first video, with the third part in the series focusing on extracting the model results, visualising the data, and model calibration. At JM Coastal, I specialise in carrying out a range of riverine and coastal modelling applications, including flooding and sediment transport. So if you'd like to know more about the work I can carry out, please get in touch at john.maskell@jmcoastal.co.uk. Visit the website at www.jmcoastal.co.uk or follow me on LinkedIn for more blog updates and information about the work I do.